This is the limit of a function part 8. Now, in some problems, you're going to find that they're going to ask you to graph some function. And so here we have f of x, and here it is, and it looks kind of kooky. So graphing this, I would just recommend just get a graphing calculator and plug it in. Now, after you plug it in, you're going to get something like this right here. And they're going to ask you, okay, so now what's the limit of f of x as x approaches negative 0? Or not, I'm sorry. What's the limit of f of x as x approaches 0 from the left? So if you're approaching this one from the left, you're going to be coming over here and you're going to go this way and you're going to get 2. So the answer to A is 2. So the limit of f of x as x approaches 0 from the left is 2. Now, what is the limit of f of x as x approaches 0 from the right? So as you're approaching from the right, you're going to come to this point. So again, you're going to be approaching 0. So this is 0. Now, but what happens if you want to find the limit of f of x as x approaches 0? Well, in this case, if you look at it, it's undefined. And the reason it's undefined is because if it's coming in from the right, it's coming in at 0. And if it's coming in from the left, it's coming into 2. So they're not coming into the same point, and therefore that is undefined. Okay, so now let's see. So now here, you might come into other problems where it says sketch some function f of x. So here we have f of x, and we're given this right here in order to graph it. So it says f of x is equal to 1 when x is less than 1, or less than negative 1. F of x is equal to x when x is less than 1 and greater than negative 1. And f of x is equal to x squared plus 1 when x is greater than 1. So if you graph this, and I'll give you a second to graph it. Pause it here. Okay, I assumed you paused it, so now I'm going to scroll down. You're going to get something like this right here. Here's the first part where x is less than negative 1, where it says it's equal to 1, so it's just a straight line. And you notice it's not equal to the negative 1 right here. That's because x has to be less than negative 1, not equal to it. The next part, you get f of x is equal to x, and then you have x is less than 1, and it's equal to or greater than negative 1. So that's why you have the straight line here. This is darkened because it's equal to or greater than. And here it's less than, so it's not filled in. And here you have x squared plus 1. It's just a parabola. And this is when x is greater than 1, so greater than 1. That's how you would graph that. Now, let's find the values of a where the limit of f of x exists. So to do this one, where does it exist in here? Well, let's see. What happens? Well, let's see. What's the limit of f of x as x approaches negative 1? Negative 1 from the left. Well, as it's approaching negative 1 from the left, it comes to the value of 1. So this would be equal to 1. But the limit of f of x as x approaches negative 1 from the right, as it's coming this way, it's actually approaching negative 1. So this is negative 1. So right here, it doesn't exist because it's undefined. It's coming in on the left side at 1, and on the right side, it's coming in at negative 1. So the limit of f of x as x approaches negative 1, that's undefined. So it doesn't exist at negative 1. So now, what about this spot? Well, it's going to be undefined here as well because it's coming in from the left to 1 and it's coming in from the right to 2. So if I was to take the limit of f of x as x approaches 1 from the left, that would be equal to 1. And if I took the limit of f of x as x approaches 1 from the right, this is going to be, oh gosh, that's sloppy, sorry. So the limit of f of x as x approaches 1 from the right, that's going to be equal to 2. So this is equal to 2. So now when I just take the limit of f of x at 1 as x approaches 1, this is going to be undefined. So again, the limit of f of x as x approaches 1 is going to be equal to undefined. So for this problem, f of x exists for all a, for all values of a, except at -1 and +1. So it exists. So this function exists all throughout here. The only places that it doesn't exist is right here, at -1 and at 1. So that's how you do these problems. I hope they helped you out, and I hope you liked the video. So good luck in your classes.